In this video, we're going to be deriving the sum and difference identities for the tangent and cotangent functions. And we'll be starting with the sum identities for cosine and sine, which are cosine of A plus B equals the cosine of A times the cosine of B minus the sine of A times the sine of B. And the sine of A plus B equals the sine of A times the cosine of B plus the cosine of A times the sine of B. And what we want to do is show that the tangent of A plus B is equal to this expression here. The tangent of A minus B is equal to this expression here. The cotangent of A plus B is equal to this expression here. And the cotangent of A minus B is equal to this expression here. But before we worry about these four equations, what we want to do is find out what cosine of A minus B and sine of A minus B are in terms of cosines and sines of A and B. Because here you see that cosine of A plus B is expressed in terms of cosine of A, cosine of B, sine of A, and sine of B. And sine of A plus B is also expressed in terms of cosine of A, cosine of B, sine of A, and sine of B. So I'm going to go up top here and work through this here. So cosine of A minus B. Well, we can say that's the same thing as cosine of A plus negative B. So cosine of A plus B is cosine of A times cosine of B minus sine of A times the sine of B. Well, I should probably write it actually. Let me work it out here. Okay, so the cosine of A minus B is equal to the cosine of A plus negative B. And that's equal to the cosine of A times the cosine of negative B. Remember here, wherever we had B, I'm just plugging in, wherever we had B in this equation, I'm just plugging in negative B in its place. Because this just says the sum of cosine of the sum of angle 1 plus angle 2 is the cosine of angle 1 times the cosine of angle 2 minus the sine of angle 1 times the sine of angle 2. So this is angle 1, and this is angle 2. So cosine of A times cosine of negative B minus the sine of A times the sine of negative B. Well, hopefully you remember from our odd and even identities that the cosine of negative B is the same thing as the cosine of B. Alright, so we'll just write down minus the sine of A, and the sine of negative B is the same thing as negative sine of B. So here 2 negatives makes a positive. This is just the cosine of A times the cosine of B plus the sine of A times the sine of B. So that's cosine of the difference. It looks just like cosine of a sum, except instead of the minus sign between the cosine A, cosine B, and the sine A, sine B terms, you have a plus sign. So this is cosine of a difference. here, I'm just gonna put a line through this stuff here. So what about sine of a difference? Well, sine of a difference, sine of a minus b, is the same thing as the sine of a plus negative b. But what is sine of a plus b? Well, I'm going to write that underneath here. The sine of a plus b is sine of a cosine of b plus cosine of a sine b. So here underneath I'm just going to write the sine of a plus b is the sine of a times the cosine of b plus the cosine of a times the sine of b. So when we're looking at the sine of a minus b, that's the sine of a plus negative b. So wherever we have b in this expression, here we can just plug in negative b. This place, so this is sine of a times the cosine of negative b plus the cosine of a times the sine of negative b. From our odd-even identities, we know the cosine of negative b is the same thing as the cosine of b, that the sine of negative b is the same thing as negative sine of b. Sine of b. So we rewrite this. It just becomes sine of a cosine of b minus cosine of a times the sine of b. So I'll just rewrite it more cleanly here. Sine of a minus b is equal to the sine of a times the cosine of b minus the cosine of a times the sine of b. So we have that and that. And we want to prove this now. Let's start with this tangent of a sum. So the tangent of a plus b, well, that's the sine of a plus b over the cosine of a plus b. Okay, but what's the sine of a plus b? Well, that was one of the ones we were given. It was sine of a times the cosine of b plus the cosine of a times the sine of b. What's the cosine of a plus b? Well, that was one of the other ones we started out with. That's just the cosine of a times the cosine of b minus the sine of a times the sine of b. Okay, but how do we get this here to look like this? How do we get tangents instead of the sines and cosines? Well, it turns out the trick we can use is divide both the numerator and denominator by the cosine of a times the cosine of b. So what we'll be doing here is dividing both this numerator, sine of a cosine of b plus cosine of a times the sine of b, we'll be dividing both by the numerator. We'll be dividing both the numerator and denominator by cosine of A times the cosine of B. But that's the same thing as multiplying. That's the same thing as multiplying by 1 over the reciprocal. So we'll say we are multiplying this by 1 over the reciprocal of cosine of A times the cosine of B. And we're doing the same thing to the denominator because to retain this equality, we can only multiply by 1. To multiply by 1, whatever change you make to the numerator, you have to make the same change to the denominator. So sine A cosine B divided by cosine A cosine B. The cosine B's cancel, and sine A over cosine A is tangent of A. This is tangent of A. This second term, cosine of A sine B times 1 over cosine of A cosine B, or you can think of it as divided by cosine A cosine B. The cosine A's cancel. You're left with sine B over cosine B, which is tangent of B. So plus tangent of B. And then in the denominator, cosine of A times cosine of B cancels with cosine of A times cosine of B. So we have 1. Then sine A times sine B. You divide that by cosine A times cosine of B. Or you can think of it as multiplying by the reciprocal of cosine of A times cosine of B. Sine A over cosine A is tangent of A. And sine B over cosine B is tangent of B. And we've just gotten the sum identity for tangent. We've gotten that. Now if we know that, how do we show that tangent of A minus B, the tangent of A minus the tangent of B, divided by 1 plus the tangent of A times the tangent of B? Well, like we got from the cosine of a sum to a cosine of a difference and the sine of a sum to the sine of a difference, we can look here and see that tangent of A minus B, it's the same thing as tangent of A plus negative B. So that's the tangent of A minus the tangent of, or plus the tangent of negative B divided by 1 plus the tangent of A times the tangent of negative B. 1 minus. We're looking at this expression here. Tangent of A minus B is the same thing as tangent of A plus negative B. So wherever you have B in this expression, you substitute negative B. So tangent of A plus tangent of negative B divided by 1 minus tangent of A times tangent of negative B. Tangent of negative B is the same thing as negative tangent of b, since tangent is an odd function. So 1 minus tangent of a times negative tangent of b. These two negatives cancel, make a positive, so you're left with tangent of a minus tangent of b over 1 plus tangent of a times tangent of b. And that's exactly what this is here. So we've proven the tangent of a sum and tangent of a difference. We have to get to the cotangent of a sum and difference now. So I'm just going to erase the work I did on the side here. Be able to rewind and copy it down if you need to. Now we're going to be looking at the cotangent of a sum. Well, cotangent of a plus b, that's equal to the cosine of a plus b over the sine of a plus b. So cosine of a sum, we remembered it is, you have it up here, cosine of a, cosine of b minus sine of a, sine of b. And this cosine of a and cosine b and sine a, sine b are multiplied. Sine of a sum is sine of a plus b is sine of a cosine of b plus cosine of a times the sine of b. But how do we get this to look like this? How do we get everything in terms of cotangents? Well, it turns out here if you divide both numerator and denominator by sine a times sine b, you'll get the necessary cancellations and conversions from cosines and sines to cotangents in order to make this expression look like this expression. So we're going to do that here. So this numerator cosine of a, cosine b minus sine a, sine b, we're going to divide that by sine a, sine b. We're going to do the same thing with the denominator. Sine a cosine b plus cosine a sine b. Divide that by sine a sine b. This numerator here of the complex fraction, cosine a over sine a is cotangent of a. Cosine b over sine b is cotangent of b. So we have the cotangent of a times the cotangent of b. Sine of a over sine a is 1. Sine b over sine b is 1. So minus 1. The denominator, sine a over sine a cancels. Cosine b over sine b is cotangent of b. And then cosine of a over sine a is cotangent of a. Sine b cancels. We have cotangent of A. And we can see this is equivalent to this expression here. So we have proven the cotangent of a sum. Now all we have left to do is prove the cotangent of a difference. And I'll erase this on the side here to give us more room. Okay, and just as we did for tangent of a difference, we'll be starting with, we'll be rewriting this cotangent of a difference, cotangent of A minus B, as the cotangent of the sum of A and negative B. And we'll be plugging into this expression wherever we see B, we will just be plugging in negative B. So cotangent of A times cotangent of negative B minus 1 for cotangent of negative B in this case, and then plus the cotangent of A. So hopefully you remember that cotangent is an odd function, so the cotangent of negative B is equal to negative cotangent of B. Negative cotangent of B. Again here, cotangent of negative B, negative cotangent of B, plus the cotangent of A. So here we have negative cotangent of A times cotangent of B minus 1. And here we have negative cotangent of B plus cotangent of A. So let's say we factored out a negative 1 from both numerator and denominator. So we pull out the negative sign. Inside the numerator, inside the parentheses, in the numerator inside the parentheses, we'll be left with cotangent of A, cotangent of B, plus 1. And in the denominator, pull out that negative sign, have cotangent of B minus cotangent of A. We have a negative sign in both the numerator and the denominator, so they can cancel. These can cancel. And we are left with, and I'm not going to write a slash through it because it'll make it look like a plus sign. We're left with cotangent of A times the cotangent of B plus 1 divided by the cotangent of B minus the cotangent of A. And that's exactly what we have here. Alright, so we've proven the sum and difference identities for tangent and cotangent, starting with the sums of sine and cosine. And along the way, we proved the difference identities for sine and cosine as well, and they are boxed here.